lesson 7.3, we are now moving on to what if you can't use the GCF for factoring, or what if after you get the GCF factored out, what you're left with is a trinomial. If it is a trinomial, then you're going to check to see, can you factor that trinomial? So today it says up here we're going to factor trinomials where a is equal to 1. Okay? So here's the type that we're talking about factoring now. We have a trinomial, ax squared plus bx plus c. And in this particular lesson, we're going to factor in when a is always equal to 1. A is always equal to 1 in the type that we're going to do today. So what type of polynomial is ax squared plus bx plus c? Okay, it is a trinomial because it has how many terms? Because it has 3 terms, we know its second name is trinomial. And then remember, we also give it its first name based on its degree. So what's its degree? 2. It has a degree 2. So that makes it a, no, that degrees are not, binomial is 2 terms. So degree 2. Remember you're supposed to, quadratic. Remember you were supposed to memorize these. Guess that didn't happen, huh? Quadratic, and you need to know how to spell these right away from the beginning. Quadratic trinomial. So when we have a quadratic trinomial, if it can be factored, not all quadratic trinomials can be factored, but I'm going to tell you right now today, all the ones we're going to do can be, because we need to practice doing it. So we're going to, as a, the ones that are in that homework, the ones we do in our notes, they're all going to be factorable. In other words, we're going to be able to rename them. And if we can factor them, the factors are often, not always, but most often, they are 2 binomials. So you'll have a binomial times another binomial as the factored name for your quadratic trinomial. So here are the steps we're going to follow. If the leading coefficient a is 1, if a is 1, here's what you can do. You will know that each of your binomial factors in the factored name will begin with the square root of the trinomial's leading term. So if it's ax squared, a is 1, that means it's 1x squared. What would be the square root of 1x squared? Or just x squared? What would be the square root of that? What times itself, that's what square root means, what times itself gives you x squared? X, 6 times x. So the square root of x squared is x, isn't it? So each binomial factor will start with x. And then the next thing we got to figure out is what will they each end with. Each binomial factor will end with the factors. We'll find a pair of numbers that when you multiply them together, they give you the last term, the c value. But at the same time, those 2 numbers that multiply to be the c value should add up to be the middle term's coefficient, b. Now this should sound familiar. This should sound like what we did in class on Friday. Wasn't that the pattern on the diamond problems worksheet? We had this diamond, the 2 numbers that were side by side. What did they do? What was the pattern? They multiplied to get the top number, and they added to get the bottom number. That's exactly what this is. They are going to multiply to get the c. Our top number is going to be the c from the trinomial, and the bottom number is going to be the b from the trinomial. So I have an example here for us. And here's what we need to be able to show. So we're going to use the diamond method to help us. C is going to be up here. Whatever the c is from the trinomial, the b is going to be down here. We're going to be looking for those 2 numbers. So first thing we're always going to do is identify a, b, and c. What does a equal? What does b equal? What does c equal? A is the number that x squared is getting multiplied by. B is the number that x is getting multiplied by. C is the constant that there are no x's involved in. So in this case, a is 1, b is 5, c is 6, just like it's written here. C went upstairs, b value went down here. What multiplies to be 6 adds up to 5. We find out it's 3 and 2 because off to the side here we show 3 times 2 equals 6. Now you don't have to show this part, the 3 times 2 equals 6, you can do that in your head. But yet it also adds up to 5. So remember, the two factors, so this is the factored name right here. The two factors start with the square root of the first term, the square root of x squared. They end with those two numbers you find that multiply to be c and add up to b. When it's a positive 3, we'll have plus 3. It's a positive 2, so it'll say plus 2. If it was a negative 3, it'd say minus 3. If it was a negative 2, it'd say minus 2. Okay, I want you to multiply those out because you're going to do this in your homework today also. I want you to see if this is a good name for x squared plus 5x plus 6. I want you to multiply it out. You could either use FOIL, or if you prefer to use the diamond, or not the diamond method, the rectangle method, you can use the rectangle method. Multiply it out. The x plus 3 times the x plus 2. What do you get? So again, you get to pick which multiplication method do you like best. Holy cow, I'm shaking things on the wall here. And after you do your multiplications, you combine the like terms, and you check to see, does the trinomial product get you, does it match the one you started with that you renamed? So, notice something about x squared plus 5x plus 6. Could it be GCF? Does that trinomial, do all three of those terms have any factor in common? They don't, do they? So if we can't GCF it, you might think it wasn't factorable. But that's not true. It's factorable, but now we have to use a different method to factor it instead. We use and you can use guess and check, which is kind of like what the directions will tell you in the book. It'll say in one section, it'll say use guess and check. You don't need to use guess and check. Go ahead and use the diamond method. Kind of like, almost in a way, like using guess and check, because you have to work until you find the right two numbers, don't you? Okay, anybody have any questions? All we've done is the check problem so far, really. Let's go to the back. Here's how we always started out. We identify A, B, and C. So what's A, Max?
X squared.
Nope.
Oh yeah,
Whatever x squared is getting multiplied by, and it won't always be 1, but today it probably will. Yeah. Today it's 1. What's the b value, Alexis? 10. What's the c value, Connor? 16. Okay, we always write that down first of all. When a is 1, we can go directly to putting the c value up, b value down. So what's our c value? 16. Our b value is 10. So we set up our diamond. Now, notice it's really not a diamond. I'm only using the x part. I didn't draw the diamond part around it. So when I say diamond, you can think x. Okay, anybody think they know the two numbers that are going to work? Alexis? 8 and 2. 8 and 2. Does it matter which side 8 is on or 2 is on? Why not? Yeah, multiplication doesn't matter whether you multiply 8 times 2 or 2 times 8. How about for adding? Does it matter for adding? No. So it doesn't matter which side. What are the factors then? A is 1, so that means we can go say, what is the square root of x squared? X. So both binomials start out with x. And now they end with what we just found here. So it's a positive 8, so plus 8. It's a positive 2, so plus 2. Here is its factored name. Do a check problem over here. Check. Because in your homework, you're going to do check problems also. So FOIL or rectangle it. Make sure it multiplies back out. And while you're multiplying, don't even look at what it was to start with. Just see what happens here. Then, when you're done multiplying, go see if it's the problem you started with. I think we did well, didn't we? Checks out. Okay, you go try number 2, totally on your own. No, remember the model goes like this: ax squared plus bx plus c. And don't let your brain trick you. The b comes before the c in the trinomial, the b comes before the c in the alphabet, but the c gets the upstairs spot in the diamond. Anybody tell me what absolutely has to be true about those two numbers? Even, don't tell me what the numbers are, just tell me something that has to be true about them. Is that? They both have to be negative. Why? Because you have a negative 7. Okay, well, I can add a positive and a negative, though, and get a negative. But it's a positive c, so they also have to, a negative times a negative is a positive. Okay, so they're both going to have to be negative. What are they? Negative 6, negative 1. So those two multiply to be positive 6. They add up to negative 7. So what's the factored name, class? X minus 6 times x minus 1. And they need to be beside each other to show multiplication. And then foil it or rectangle it and see if it checks out. Foil this time. Just to be different. I foiled it, mine checked out. You may rectangle it. Check out that way also. Okay, so now, let's just start starting to realize there's another pattern going on here besides the two numbers multiplying to be c and adding up to b. If I come to your paper within a second or two, I can just look and I can check on the c value and the b value. If you've written them down correctly, I can go directly to your factor name. And I'm not going to tell you whether you have the right factors, but I'm going to be able to look and say, you know what, I already know you don't have the right factor name. Because I'm going to look at the signs that are going on in your factors. So, the first one ended up with 2 additions, didn't it, in the binomials? What has to be true for there to be 2 additions? They both have to be positive, yeah, okay, that's what that means. Two additions means they're both positive. What has to be true about the C and or the B? If both of your numbers are going to be positive, which creates an addition in both binomials, what has to always hold true about the C and B? All I have to do is look at your C and B, and I can say, you know what? You're right, or you're wrong. And I won't even really have to stand there very long enough. Both C and B have to be positive. Yeah, because if you multiply positives and you add positives, what happens? You get a positive either way. So the C, when both the B and the C are positive, I know, and so should you know, that in your binomials you better have two additions. What happened when we ended up with subtraction in both of them, like this last one? What do you think we can always count on? How will I know? If you have two subtractions going on in your factors, I look and I say, you know what? I'm feeling fairly confident about this right now. Or I'm saying, you know what? I already know right away that you have something wrong. What am I going to look at to be able to tell you that you have it right or you have it wrong? Is there, you have two subtractions. What's going on in this number two? Pay attention to the B and the C. B is negative. C is positive. Two negatives multiplied make a positive. Two negatives added make a negative. So remember, they got to add the B up to the B value. So if B is negative and C is positive, I know. I don't have to even stand at your spot very long. I can say, if you don't have two subtractions going on, there's a problem. Okay, go ahead and do these last two. Let's see what happens in those. If you have any questions along the way, make sure you're asking. I'm kind of letting you be on your own here. And if I have anybody who's done and willing to come up here and do one of them at the board, I would love that. I'm good at starting for you anyway. I won't make you do the check problem at the board. Just go to the ABC, the diamond, and the factor name. Will come in everybody else's check problems. Ready to go do that, Cameron, for me? You can do either or. You take your pick. Oh, I think you're looking at number two. Okay. I think you looked at number two, am I right? Yeah. Okay, we'll get this out of here. Let's try that again. Because you had the A, B, and the C right, and then I think your eyes just went up to the problem before. Okay, here you go. Okay, thanks, Karen. Anybody gonna do number four for us? Come on up. I'm not doing it, so come on up. Would you verify that you agree with Cameron on three? If you've done a check problem, only if you've done a check problem, then you can say it's right. Is he right on number three? Yeah? Okay. Number four. He doesn't get to do that one for you, too. Those of you who are sitting there waiting for Trevor to, after you're done, waiting to see if we agree with him or not, would you look for some sort of a pattern now that you're going to be like, no matter what, here's what I can count on. Every time I see this, I know this better be happening in my factors. get into the stuff if you didn't have good multiplication skills. You might pull your hair out sometimes. Trevor. And Trevor, I'm going to trust you to check problem. And checked out. Anybody agree with Trevor's answer? And you guys check problems also? Okay. Anybody think there's something else then that we can count on now? Yes, Connor.
Number 3,
Uh-huh.
negative 3 and 7. That adds up to your b value.
Okay.
And then 4, negative 6, and 3 add up to your b value.
Yep, and they need to. Okay. Well, in one of them the b value is positive and the other one it's negative. So do you think we can count on something all the time with the b value if it's negative or if it's positive? In these situations, do you think there's anything we can count on that is going to be hold true in the factors? Notice something about the factors for me. One factor has a negative, which is a subtraction then, right? And the other factor has the positive, which ends up being addition, right? So both of them have in their factor name, one factor has subtraction, the other has addition. But yet in one of them the b is positive and the other one the b is negative. So I'm not sure where there's any conclusion we can make there. But I bet there's another conclusion that we can make that you should be able to say, you know what, every time I see this, I know I'm going to have subtraction in one and addition in the other. It's the negative c value. Because when you multiply two numbers, doesn't one of them have to be negative and the other has to be positive? A negative times a positive is a negative. So if you have a negative c value, you better have subtraction in one of them and addition in the other. But then do you have to be careful which one? Do you have to make sure? Well, yeah, you do. Because would this, look at here, if I made this a positive 3 and made this a negative 7, would that have worked? No, because now when I add them up, I get a negative 4. But yet it multiplies to be negative 21, doesn't it? Yeah, so I still get my negative c value. I still get the right c value, but if I put the sign on the wrong number in my pair, I'm not going to get my b value to add up the way it should. So we do have to be careful. The b value, you know what, sometimes it'll end up positive, sometimes it'll end up negative, because what happens when you add a positive and a negative? Can you always count on that the answer will be negative or the answer will be positive? What's negative 10 plus 3? Negative 7. What's 10 plus negative 3? Positive 7. So when you're adding a positive and a negative, can you always say the result will either be positive? Will always be positive? Can you say when you're adding a positive and negative, the result will always be negative? You can't say anything about that, but you can say that when you multiply a positive and a negative, you will always get a negative. So when the c value is negative, we should know that our two numbers have to turn out to be one positive and the other negative, and we want to make sure we give the negative sign. Oopsie, now I went and did it wrong. We've got to make sure we give the negative sign to the correct one, right? Okay, let's get you started on your homework.